Done now? Yeah, it's on now. Yeah. Okay. Fine. Yeah. So just to kind of quickly brief what we have done so far, and all the stuff is available in the previous recordings. So if you could not follow today, you can quickly go back and look at those recordings, and they should help you out. So we started with this book, Machine Learning on Kubernetes, but due to some reason of the book version and the content version and so on, right? So we thought of we'll cover the topics, but eventually, I mean, we'll cover topics individually, and then we'll go back with the final few examples, what they have in the book, so that it covers that book as well as our content. So that is what we decided. We have kind of made a good progress so far. And as you know, this particular topic we are not targeting as a machine learning engineer, but as a Kubernetes or a DevOps or MLOps engineer, where machine learning models are being built, and we are going to deploy them on a container and a Kubernetes cluster. So in the earlier sessions, we of course looked at the MLOps overview, some of the component of machine learning. But in the last two sessions, we basically looked at how we can create a model. So we took a very small data set of of a house pricing, like house size and the price of it, and we used machine learning model, linear regression, to kind of build a very simple prediction thing. So it was, I'll quickly show the code actually, that would make sense. So again, yeah, so I had it, I don't have it in Domain. I was kind of trying it out on the VM on the cloud. So yeah, something what this is what we have done earlier. Again, don't need to kind of take too much of what we call say worry about this particular thing what we are doing. So we simply took up a CSV file, and what the CSV file has, as we saw earlier as well. Okay. Oh, yeah, yeah. So this particular file is contained only the size of a house and the price. Again, very small data set. So what we do is we're trying to teach our model, saying that okay, hey, this is how the pricing looks like in our neighborhood. This particular size apartment is going to sell at a given price. Again, we can say USD, INR, whatever you want to understand for the pricing there. So we kind of learn some pattern from it, and then we predict. That is what we are trying to do here, right? So we learn the pattern, and then we do our stuff. So that's what is there. And what we did earlier is we basically did our basic stuff, and then we packaged this model into a file, which is nothing but like with the pickle module of Python. So we take into a file and write it. So basically, we are creating a .pkl file, and this PKL file is nothing but is whatever the model you have built. So whatever the models you have been seeing in the market, something like this is there. So basically you have a data, from there you learn something, then you create a model, and then you start serving it. So what we see is we now built a model, and then we also saw how we can take this model, put it into a Docker file, and then we can serve over a endpoint. So we also saw with demo last week from Francisco, that how we can take this particular container what we have built, and we can take it to Kubernetes. So all these things has been covered already. But in a nutshell, you have some data, you learn some pattern from it, then you package that pattern on a container or on a then you can deploy on Kubernetes cluster. That's something what we have done, and of course you can go back and look at the previous recording. So I'll not go too much on that. If you have a question, you can tell me. You can ask right now. If you have a specific question. Okay. If it is, please let me. Okay. So now this is something what we have done. Now what we're trying to do is we are trying to go to the next thing. So now in this particular, so we kind of saw till here notebooks we saw how to serve the model as well, at least in Docker and Kubernetes terms, and then we were saying that would explore either MLflow or Kubeflow. Now, again, MLflow is a tool which would basically, again, I'll explain it right now. So Kubeflow and MLflow are the tools which are being used in the industry a lot to train the model. I would not say, yeah, they're two different things, but for now we can think about what difference I can see that MLflow is just a Python module which you can quickly install and get going. While for the Kubeflow, you would require a lot of infra, like Kubernetes cluster to be set up and all those things. So Kubeflow would require some additional setup and all those things, which is good. But I'm not an expert right now to kind of comment further on that. Maybe if all of us are there, I mean, if all of us agree, we can look at one session on Kubeflow as well later point of time. But today's topic is MLflow. So we picked up MLflow, which I think pretty straightforward and easy as well to kind of get going even your laptop to kind of cover at least part of the MLOps cycle, right? So with that, I'll quickly get my slide deck and then we'll discuss from there onwards. Yeah.
So is Kubeflow just a way to run MLflow on Kubernetes
No, no,
or
no, no, no. MLflow and Kubeflow are two different projects altogether.
two different projects altogether?
Yeah, yeah. So people would either go with Kubeflow or MLflow, and maybe in some cases you'll mix them as well. So
Mm.
Kubeflow requires Kubernetes to be in place, which kind of makes it a bit too heavy, which I think that's the
Mm.
case right now. And it
Mm.
does not have all the features what is required in the entire MLOps pipeline as a one single entity. So you need to kind of plug in a few different things there. But again, my knowledge to Kubeflow is very limited right now, so maybe in some other time we can explore and talk about it. Um,
Okay. Thanks.
so MLflow is something which I think from a company called Databricks, which I believe all of you would have heard. So it's an open source tool, and what it says that it is a tool to for managing the machine learning life cycle. So let me quickly kind of come here to kind of understand what do we mean by the entire cycle. So I think maybe yeah, let's just look at this particular slide first. What we saw so far is we built a model, we packaged it, and we deployed into a container and running on Kubernetes perfectly fine. But of course, the model once you have built, it would require some changes. Or let's say you have built a model from the last 1 month of data, and that model is serving. But then you kind of do more data collection, and now you have 6 months of data or for whatever months of data now, and you want to make that model more accurate, right? So that there is no issue like of somebody is giving you wrong answers or it is not up to the mark, right? So we want to retrain the model again and then again serve for the better result from our model, correct? So simple example can be, let's say, uh, yeah, let's say you're predicting the yeah, house price itself, right? Now, what we know that, right, we talked about last time as well, right? So today, house price of a given size, let's say X, right? Now, let's say government announces that in that particular area, we are going to open up an airport or let's say whatever the metro train or whatever it is, right? So some development is happening in the new area. Now, because of that particular announcement, the price is going to go high, right? Right. So whatever data you had 1 month before, it may not valid anymore, right? Because something has changed. So you need to kind of rebuild the model so that it can fit the right pricing now. Correct. That's an example which is there. Similarly, it can be anything, right? For example, ticket pricing, something has changed. There is weather is changing, something like that, right? Insurance. So all of these things require continuous iteration, right? It's not that you build a model once and it runs throughout and it do a prediction of all the right things, right? It would change as per the new changes, right? So the simple thing is that you need to continuously um, update the model and train the model to do the better prediction. That is what you want to do. And of course, as a DevOps engineer, you would say it's a very common thing, right? That we have to continuously do things. Same thing is going to happen here also. Now here, what's going to change is the algorithm what you would use to predict, for example, or there's something called as hyperparameters or features and so on. So, for example, think about earlier you took only 5 features. So, for example, you went for a data collection in the field, right? And in the field, you collected 20 feature sets, right? Let's say for the house itself, you decided to kind of pick up 20 parameters, which can be the location from school, then your, I think we covered that in the previous somewhere, right? Yeah, like this one, right? So you have taken some of these features, right? And suppose there are 20 such features you have taken, 20 such options you have taken. Based on that, uh, you did data collection of 20 different features. Now, while building the model, let's say you have taken only 10 parameters right now to build the model, and it's doing a prediction. So though you had 20 data points, but you considered only 10, which you think is valid right now. But then, because of those only 10 features, your prediction not coming properly. So what you would want to do is you want to add more features. Let's say you want to get 15 features to now build a model. Similarly, so that's a change in the model itself, right? The way you train the model, right? Similarly, there can be some parameters which they call hyperparameters, which I'm not too expert on that, but there's some parameters to kind of do some analysis of the data itself. So all those things are there. So what I'm trying to come here is that there are going to be so many parameters which continuously keep changing, and you cannot manage it on its own, right? So for example, um, for a experiment one, you have taken 10 features. For experiment two, you've taken 20 features. Then you've taken different parameters to do some tuning kind of a thing, right? And manually, you can't uh, put them in an Excel sheet, right? Because what may have, you may also have data along with it, right? You would build a model. How would you save the model and all those things, right? So the idea is that what I want is when I'm doing my experiments, I want to track each and everything and which I can compare later. So, for example, you did 50 such experiments or 50 such runs of a given experiment, whatever, right? Now, I want to compare which is better. And how do you compare? Of course, you would do some evaluation. So there are some different criteria what you have for evaluating a model, right? So we talked about something called as RMSE. I think root mean squares in the first session itself, second session itself, where whatever the model you have built, how deviation it is happening from prediction. So we saw that okay, if my model predict for a given house size, the price is $1,000. I'm just giving a number, but actual when it got sold to $1,500, something like that, right? So that difference is $500 between my prediction and the actual price, correct? Something you kind of compare, right? So you have to evaluate how is the prediction coming. So for that, different things are there. So I have now 50 such experiments I have done. I want to now evaluate, say, which model is best. So there has to be criteria, correct? So that way, I will do comparison and decide which model to take forward further. So for that purpose, we really require to do this tracking, and that is where ML flow can come into picture. So ML flow has more than this feature, but tracking is one of the good feature what it has. Any questions here? All okay? So far so good. Okay, fine. Think about it. Any questions? Please let me know. Okay, great. Fine. So let's continue in that case. Come on. Yeah. Yeah. So MLflow is a tool which is going to help us with that cycle. So it kind of has different features, right? So what we can do with particular MLflow, we can do the experiment tracking. That's one part of it. Then we are going to do visualization. So whatever experiment we have built, we can visualize different performance of it. Then we can of course store the models. We can store the models in the registry, like the way Docker registry we have. Similarly, we have model registry, which is provided by the MLflow. Then we can do serving. So basically, we can connect MLflow with the tools like Docker, Kubernetes, and say from the MLflow itself, we can deploy and deployment to Kubernetes cluster. Then they have other features for generative AI, and evaluation is one of the key features they have. So I can do evaluation between different models, performance of it, right? And they also got some feature about generative AI that I can build my own prompt engineering UI and all that stuff. So I have not experimented that for now. We'll see. This I think is very clear. This is what is going to be required. This is something which has to happen continuously, correct? And this is where our ML flow is going to come in very handy. Okay, so now who is going to use ML flow? So this is given by from the ML flow website itself. Like there are different. So we already saw for the ML for the entire ML ops, there are different personas we have, and there are different uh, what do you call say different stages we have there, right? At every stage, different persona is going to work. So for the given persona, how they're going to use ML flow, that is what has been mentioned here. Correct? Somebody who is data engineer, they would focus on preparation and data analysis in the beginning, right? Then for feature engineering, data scientist would kind of do these things, right? They kind of overlap something, right? ML engineer is going to kind of do the model validation, deployment, and monitoring of it. And who is data governance officer? He's going to use or he's going to use entire stuff. Correct? So ML flow can be used for different purpose. So this is what kind of given on the site, right? So hope this makes sense to everybody. Any questions here? Okay, great. Um, So MLflow, I think I talked about here. What are the features of MLflow? So I think this is perfectly fine. Let's look at some demos and then we come back with the slides and see what it is, right? Okay. So what I have done is I have prepared kind of a say same example, but I've taken a bigger data set. So earlier we saw that we had this house.csv, right? House price.csv, correct? It only had a few parameters there. So what I have done is I have got a kind of a much bigger data set, which I think I got from Kaggle. So train.csv. This is the pricing of the houses in Bangalore available on Kaggle. So I've just taken it and just changed some headings there, but data is taken from um, I think it's across India actually, not just Bangalore. You can see different cities here, so it's across India. Perfect, fine. Some data is there, so don't again. We'll not go into the model building and all those things. We'll focus on ML flow, right? That is our target for today, right? So now, what I have here is I have kind of built 5 of different demos here. So again, this is a very raw demo, so I don't have a lot of automation, all those things in place, but raw learning you can say here, right? So what I have taken here is again, what we have to focus on here is the yeah. So what we have to focus? Just give me a minute. Yeah, I'll just come back. Just give me a minute. Yeah. So what we have to focus right now is this is our function, the main function. Under that, what we are doing is we are loading a file. This is train.csv file. And again, we kind of got our fields which I want to train on, the size and the price there. That is what is being done here, correct? And then we saw it earlier that we are splitting the data set into training and testing phases. That's perfectly fine. And then what we have done here is, okay, I think 1 minute, not this one. that is also fine, but I just want to check if I can give you a much more simpler example. Yeah. Mm. I should have use VS Code here. As I was building remotely, I did not. Okay, fine. So this doesn't have any MLflow component right now. So what we are seeing here is again I start with here. So I'm having some CSV file which has my data, and then we are using this split of data set training and testing purpose, and then we are using Slastic net. There's a function to kind of say as an algorithm through which we can train our model. So that's what we are doing here. And why I use Elastic net, or from the example which I have got on the internet, because it takes two parameters. So the idea was that when we are building this ML models, or data scientists when they're building is, they're going to play with different parameters to get the right model, right? So because this example uses this elastic net with two parameters, that is why I took it, and that's how we can see that how it affects our results, right? So what we are doing here is we are taking two parameters alpha and L1 ratio, which we can pass as a command and argument. Otherwise, the default value is zero 0.5. That's the thing what is there. Um, and then we have this evaluation function, through which basically what we are doing is we are going to pass our prediction and the data what we got exactly from the test data set, right? And compare what difference it is there. So I was telling you about, right, prediction and the actual data, what actual value what we have. We do a comparison. So again, we can keep this aside that what is data science stuff, but there is some function which can give us evaluation of our prediction what we are doing. Correct. So let me run it here. This program. Hope it's still pretty straightforward, not too difficult for anyone. Yeah. Yes, it gives some value here. So it's telling us what is the value of alpha, correct? And what is this RMSE, MEA, and some variables or some parameters through which the data scientist can say that, okay, this particular model is good or bad, right? Something like that they can say, right? So this is a simple example, what we have, and I think continuation of the previous one. Now we are going to bring in the ML flow into the picture, into the mix here, right? Um, okay, so let's do that. Let me see. Okay, so where I'm running this particular thing. Mhm. Okay, let me just kill it right now. I thought. Okay, how? Because okay, let me just do a kill. Doesn't matter. Shouldn't be a problem per se. Yeah, I thought I'll just kill it before the demo, but I did not. So let me just. As if I come on, copy paste.
Oh, you're running outside of Docker.
Yeah, correct. Yeah. At this point of time. So there's no ML flow right now in the picture. Yeah. Mm. Okay, so there's some information from David. Thanks, David, for putting that information here. Yeah. Okay. Fine. So let's kind of go ahead and um, show you how this particular program has been built now. So I have this demo one here. So what I have done is just to kind of show a difference here, right? So I'll just show a difference at every line, at every uh, example what I've been building, so that way you know that how it has been changed, right? So now you can see here what I'm doing is there are few changes, right? One is of course we are adding this MLflow library or module on the Python, correct? That is one change what has been done. The second change what we have done is we have given this experiment name. So what happens when you run MLflow? You need to define an experiment name for which it generates an experimental ID inside it and so on. And for a given experiment, you can have multiple runs. So for example, I'm giving it experiment one, but then I can have different parameter changes here. For example, again, change that alpha and those parameters, right? So with those, I'll have different runs. So under under our experiment, there can be multiple runs. Okay. So let me do one more thing here to kind of make sure our exam, our thing is completely clean. I'm going to remove this ML runs folder here, which is going to get created. So currently we don't have any folder called ML runs, but once we kind of run this program, so what happened is we just added this MLflow module here. We then said that I want to run, I want to kind of create an experiment. And then what we are doing next up is whatever was written here, right? In the previous thing, we are saying it, run it under the MLflow start run block, correct? So we take the MLflow library, we define the experiment, and then whatever what we are saying is whatever we were doing earlier, do it under this with block of MLflow start run. That's all the change what we have done so far. Any questions here? Clear, right? Nothing.
Yeah, it's clear.
Yeah, great. Let's go ahead and basically run our program um, with the MLflow on, right? So, okay, Python 3 I have to mention, right? So now what happened is something is there. Okay, so it's saying connection refused. Uh, why this? What is trying to do? Okay, so it is we are not running MLflow. It
Yeah,
isn't.
you just killed the server, right?
No, it doesn't require actually. Okay, I think I got the problem. Okay, so set. Uh, I was setting an environment variable that may be causing the problem. Oops. Yeah, this should be a problem. This was a problem. So actually, so to run the ML flow, you can do everything ML. Okay, so let me just unset this environment variable first. Experimenting few things. Yeah, sorry. So now that variable would have gone, I believe, should be. So now if I run, you can see that it is going to run. So there's nothing, right? I just added this ML flow module uh, and um make those changes, minor changes there, right? So what happens now is again, you don't require any third server here to run MLflow. Just MLflow running locally on a machine. And what happens? You now see this ML runs folder, which was not there earlier, which we removed, right? This was not there earlier. And under this ML runs folder, you can see that I have got this ID. So 0 is the default one which gets created for the init purpose. Forget about 0 or default we call it. This is the experiment ID which we created, correct? So if I go under this experiment ID, you can see I can find some information here. I'll go to this run. So experiment can have multiple runs. So experiment and the run, right? And you can see here like parameters, right? So currently nothing is there. Meta information, we may have something, right? So let's do a cat of this. Some information is there. Whatever has been kind of picked up here, run name is there and all those things, right? So what we did simply is we just add a module and run under a with ML block. So far so good. Any questions here? Okay, no, great. So now what I'll do is I'm going to show you the second program. So now the next version of it, right? So now again, we'll see what change I have made. So this is the current version, and just we're doing that MLflow enablement, and then I'm going to do the second one here. Yeah. So now what I'm doing here, so again, nothing changed here. What I'm just doing is I just say that enable some logging, because we did not get any data in our logs. So what I meant to say that uh, in the ML runs, right? When we are opening that ML runs, and when we went to our run and experiment, right? And when we went to parameters, everything was empty, nothing was there, right? It was like an empty thing, nothing was there because nothing got logged, right? We just ran under MLflow. So now what I'm saying is here, what say enable the logging. So now I'm saying that log that these parameters as the run happens, which is the alpha, whatever is alpha, whatever L1 ratio, RMSE, ME, R2, correct? So I'm saying that as you make this run, log these parameters for me, right? So now again, I kind of go and run this program here. Yeah, right. So I run the program. So now what's going to happen is it is going to have another run under the same experiment, right? So again, we can kind of go and check that. So under ML runs, the experiment ID. Now I will have a second ID also, which is the run ID, correct? This I believe the new one, right? Or the old one. This is I think, yeah, this is the new one, right? So you can now see that these are getting recorded, correct? Make sense? So you have recorded some stuff under the ML flow. So far, so good. Okay. Now what I'll do is I'm going to run a command called mlflow UI. That's all I'm running. And what happening? So I'll just make one more change here because it will not be available publicly available. So I'll just say mlflow UI and -h, make it on public URL, right? Yeah. So now what's going to happen is going to now serve on port 5000, right? So I'm just going to open that URL. I'll bring it on the screen. Yeah. So now you can see that again. So these can run locally. So again, we are not talking to anything else. You can manage all of these models management locally only. You can see now I have got this experiment one. That is the name what we have given in our code, as you can remember. If you remember that in our code, we have given that experiment name, right? Where it is, this one, right? Yeah. So now you can see here for we did two experiments, and for those two experiments we have these numbers available here, that name available here. I can go to a given run here, and then I can check out the parameters, what has there, what is the metrics I have got, right? I can look at like again, this is the same thing is a graphical format and artifact, which is not there right now. So I'll talk about that as we continue, right? So now our local developer can also use MLflow on their stuff and manage all these things, right? I can run MLflow on my laptop and have these things available for me to kind of compare different version and all that stuff. So I can actually go back here and I can pick up these two for now and say compare. So okay, I think all three compare. So again, nothing much here right now, but you can see that I can now do a comparison of few runs here, right? So this is how you can run this ML flow locally and kind of get this kind of information. Any questions here? Sorry.
No, I think we're good.
Okay. I think some. If you're not speaking, can you mute? Yeah, some sound or something. Okay. Fine. So let's now go with the next one now. So we saw two steps. Go third step now. So again, we'll do the same stuff. Vim diff. To make sure that we kind of go step by step. So we did this. Yeah. So now what I'm doing the next step is I am trying to say that whatever model I am building. So as I am building the running the program, or when I build a model, I want to save that model as an artifact, correct? Because as a part of the process of building it, right, I would, as a process of running this particular thing, I would build a model, and I want that model to be available for me to consume further, correct? So for that purpose, again, as usual, we know artifacts, what artifacts are. So this is already covered at how we can dump our model into a file. Now what we are doing, next step is we are saying that log that artifact, correct, into this particular folder. So again, we have this model folder right now, which I'll just empty it out for now. So here we have this models folder, which has the model. So I'll just remove this file as well right now. Yeah. So nothing is there's this point of time, correct? So just want to make sure nothing is there's no folder called models now, right? So now what the next step for us is I want to save my model as artifact in my um, in my MLflow, right? So let's run this. Um, okay, so okay, I think yeah, I think there is some problem. 1 minute. Yeah, so okay, this is building locally actually at the same folder, I believe. No, what it is, it should actually do it right. Signal.dump, open file. Uh, let me
I think
remove.
you'll have to create the directory models. If you have you also deleted the directory as well?
Yeah, we did right. Yes, correct. Yeah. Let me do that actually once. Yeah, let me with the reasons. Let me with the reason one of it. Let's see. Yeah, correct. So that folder should have been okay. So now what would have happened is in our models folder, we would have got this lr.pkl. And now if I kind of go back to the UI, right? So again, the same stuff, right? We have our MLflow reviewing the current. So again, as you can see the failure also here, right? So we did run and we saw some failure that has also been coming up here, correct? So then I can kind of go back to this one, and now I can check the artifacts, and you can see I have got my artifact available with me, which I can download and take it further, correct? So this way I can track all of these models, correct? As I am kind of building, because I'm experimenting at a like quickly I'm doing it, but eventually once I compare, I can go back and compare, right? How do they compare, right? So I can go to the models, I can quickly select and then compare. Right? Let's try to compare one change what we'll do in our thing right now. So let's do a quick change here. So currently this is our these things are coming this RMSE and this is coming here, right? So what I'll do is I'm just going to quickly change here while doing this train thing, right? Where is it? Yeah. So what I'll do is I split my data set, right? So I'm going to say split now. So earlier I'm using zero point 0.8 for my test purpose. Let me do 0.5 now. I made some change here, zero point 0.4 or zero point 0.5, right? So now when I run the program, this should actually give me a different RMSE and all this stuff. Something changed. Yeah, so you can see here, my model has now reduced the performance, right? It is now 592, which was earlier 612. I'm assuming that higher is better here, right? Correct me if I'm wrong, but some changes there with the numbers here, right? So I can see now the previous and the current has some comparison or some different numbers here, right? So let's go back to our thing here. And again, we'll have one more experiment here. So we can pick up last two and do the compare. This does not say anything. 0.5 and this. Now, at least here we can compare the different numbers here. Let's say we can do some plotting. So plotting, I think we don't have enough data right now. I did once, which is again, I think was confusing for me, but I think data scientists can make sense. But at least you can compare here that by the way, we can compare right now. If I have two different runs, I can find out how much time it took for doing the run the stuff entire thing and what are the parameters being used and what the data I have got, right? This way, I can basically compare different models. Any questions?
So what do you see? You see the box plot. What visualizations do you see?
Box plot is not coming yet. It should actually come. Okay, let's
Oh, you got
try.
to choose the X and Y axes.
Yeah, yeah, correct. Yeah, so choose by
Nice.
default and something. Yeah, yeah. So I think yes, we can compare against some of these. Yes. Yeah. If you make sense out of it, let us know what it is. But for me, it's a black box.
Oh yeah, this is showing for a given hyperparameter alpha, which is
Yeah.
I think the regularization parameter for ridge LSO or elastic net,
Yes.
showing
Right.
you what is the RMSE.
Mhm.
And if you got like 10 different runs, it will show you the distribution.
Yeah. So if we have to if we just do a lot of runs, we can find out. Let's do one more thing. Let's just take one more run and then see if it makes some differences here. So let's just change these parameters also. I think these parameters we can pass with these two parameters, these two things, alpha and L1 ratio, right? So let's just do this and see. Let's just say 0.2 L1 ratio. Hyphen, okay, underscore. Yeah, so something is not different. Let's go back and let's compare last three runs. Yeah, something is now coming better. Something interesting is coming. Let's see in the box plot. Okay, alpha. Okay, yeah, something is there. Yeah, this is very colorful, right?
We need to bring in the experts,
Yes.
all the police.
Okay. Could you go to the parallel coordinates plot? I think that's
Which
cool.
one? This one.
The first one,
Yeah.
yeah. That's just here you can track each individual run and what was
Yeah.
their outcome.
Yeah. You can see how the thing is going up, down, kind of a thing, right? I believe. Alpha is this, right? Ratio is this, and this is your MA. So yeah, you can. But how do you make which run was it? How do you see
Oh,
that?
you follow the line. So the one at the top goes down diagonally.
Uh-huh.
So that had 0.5 for alpha and 0.5 for L1, and then
Uh-huh.
the result was 136 MAE.
Okay.
Yeah, you follow each line. Each line is a
Okay, so
run.
alpha. Okay, so you start with here and then you look at all this run. Understood. Understood.
Exactly.
Yes.
Yeah.
Understood. Understood. Okay. Great. Something new. Yeah. I was wondering how to read this particular diagram, particular things. I saw it earlier, but yeah, good. Yeah, you can choose from here, and then based on that, okay, this would change. Understood. Okay, makes sense. Makes sense. Okay. Okay, nice. Got it. So you kind of follow the line and then see how it's going to be. Yeah, makes sense. Okay, thank you. Okay, so let's kind of look at our next demo part. So we did three, right? Yeah. Let's look at what is the difference between three and four. That's the one, and then I had this fourth one. Yeah, so now what change I'm making? Yeah, so now what I'm doing is rather than having the MLflow running locally, so what we did right now so far is we had the MLflow running in the, so it's like a, it's called a local setup, right? So everything whatever you're doing, it is happening in your current folder called demos. Under that demos folder, we have this ML runs, and in that we are having both these things, right? ML runs and the models one, right? But then what we can do is we can also configure MLflow to be somewhere else, maybe a different machine altogether, and then we can point out our current run saying that now this is your tracking URI. So you can need to kind of go to this particular endpoint to put down your content, right? So the free version of MLflow, which we are using, doesn't have an authentication per se. But if you use Databricks, you can, I think, add some authentication as well. But for now, as a part of demo purpose, we will now deploy the MLflow to run, assuming it's running on a remote machine, and then we'll connect, and then we can dump our data there, right? That's the idea. Okay, so for that purpose, I need to get a command here. How did I run it earlier? Yeah, so not this one. Let me really get it from the site itself. Flow documentation. Okay. Yeah, I think I can do with this. So I can set up more options here. So let's just say if I look at the MLflow command itself, right? You can understand different options it can give. So with MLflow, when I'm kind of, okay, let's do a server option, MLflow server. Maybe before that, let's look at the itself, right? So MLflow can behave as a different entity itself, right? So for example, you can have, I think, model artifact somewhere else. You can have server somewhere else and all that stuff. So you can configure the same binary to perform different things, right? So because it has different personas as a part of itself, right? We look at server for now, and we can see for the server itself, it has many options available, um, like backend storage. Then you can have like where would it's kind of store all the backend data, what is kind of doing it, so you can store in a file and database, registry URIs, and so on. So you can have configure the server for different parameters, where you can use databases of different types to configure, have whatever the parameters it is being saving and all that stuff, right? So you can configure ML flow to have the data saved in different format, like maybe in a file, in a database, and those kind of things, right? Again, we'll keep it simple for now, and maybe in future we kind of look at different examples. So for now, I'm just going to say that, okay, run this ML flow on my endpoint. So I'll pick up a different folder now rather than this here. So let me create another folder on the /tmp. So I'm here, and now if I just run this thing, right? So now I'm deploying this. So now you can see that it is now running at a public URL. We saw it earlier as well, but now we are doing it. Okay, I want to access it over the public endpoint, and of course I can pass different parameters here to have backend storage and all that stuff here, so which you can explore later. For now, let's kind of go back to our URL, and we'll open up different ports here. 8080, right? Or was it 8880? Yeah. Yeah, so you can see now it's clean now, clean setup right now. It is not there, right? So no, there's no runs. Only default one is there. Now what we'll do is we'll go back to our demo here. So what I'm doing is now I'm saying that set this tracking URL to be a remote endpoint, and remaining things are same. I think the parameters of this test is perfectly okay, doesn't matter because we just changed that. But only change what I've done is saying that now it's a remote endpoint for you in this particular example. So again, similar run, but now this time it should go on our remote URL. Right? This is how it is. So now the same kind of information what I had previously is available now on the remote endpoint. Any questions? Pretty straightforward, right? Yeah. Okay, great. So now I have just one more thing left for now, and then we'll look at just I think on time as well. What's happening? Yeah. So now in the next example, what I have done is let me just open up. Okay, let me just show you artifact not three. Okay, let me just open directly that particular example here. So in the last example, only one change I have done actually. So instead of earlier doing the yeah, okay, I think I would have to do it actually. I can't skip it. So vim diff and sorry, vim diff. I'll take one change actually. Sorry. Oh, this line. Yeah. So where is the food file? Yeah. So now as you can see, the only change what we have done here is actually two changes I have done. So MLflow supports auto logging. For some of the models, it has support of auto logging. So if you don't specify anything, like in this case, what I'm doing in the next example, I have enabled auto logging and I have taken away all of these parameters. So I'm not doing anything manually here, correct? Like in this, the new case, right? So it was there in the previous one, but as I have enabled auto logging, I don't require to mention all of these parameters here. So just run a program and say ML flow auto log, right? That's all.
So
Even
how does it know what are the right metrics based on whether the
yes,
model
that
is
has been
for
yeah. So that
classification or regression?
yeah, that is depending on the model. So currently it is okay. Let me run. I'll show you, right? Let me just run this program. So what happens is this is going to say that okay. Let me draw it. So let it run. So you can see here it's saying that outlogging has been enabled for sklearn, right? So it realized that okay, under this program we are using sklearn, and I would enable logging for it, correct? And now it will pick up whatever are default been configured for sklearn, and of course you can add more of these more parameters if you would wish. Otherwise, so sklearn automatically has some setup. So let me now go to the UI and then we'll see it what has happened here. So now with the latest example, you can see here first what difference you can see I got dataset also as a part of it, correct? So this is the new run which you have done, and you can see these parameters have come automatically. So this is because of it has this sklearn built-in settings, and based on it has got. What has not got our RMSE, it is R2 score is there. This is like different name per se, but same thing, right? Mean squared error kind of a thing or whatever. Yeah, I think this one, right? Root mean squared error, correct? So earlier we were giving specifically RMSE, but here it has got this parameters, what has been default been there. Okay, and of course you can add custom if you would wish, and it will also come. Make sense?
Cool.
Yeah, and the rest are all going to be same here. Now what we can also do is once we have logged here there, we can also do a registration of model. So what we can do with particular, so currently we just saw how we can put our model in the or we just saw how we can track the models. Now let's say we've got 5 models or 10 models, whatever are there, and one model we think it's good, right? I can take it to the next level. So what I can do is I can do the registration of that model, registered model, and what will happen in this case is this model would get stored in the register or in the model registry what we have, like a Docker registry we have. Similarly here, if you think out of these 10 runs, this model seems to be good for me, correct? So I can take this model and put in a registry, right? So let me give a name, for example, demo, for example, for now. So I would say register, sorry. models, create a new model, sorry, yeah, no, not new models, and demo. And that's how my model is registered here, and I'll find this demo model here, correct? So now once model is available for me, I can take this model for our deployment purpose, which I think we'll cover in the next session and so on. Make sense?
Yep.
So could you take that model and then use MLflow to serve it, or
No.
is MLflow capable of doing that?
No. So it has a deployment option. So I was trying that, but I could not make it run actually at this point of time. But we'll see that. So we have an example of yeah, like this, right? So develop a model and deploy on Kubernetes. That's a demo they have given. So I think we have already covered in this part here, model building, seeing all that stuff here. So now what can happen is once you have this ML model, right, you can see for each ML model, you will have these run IDs. So currently they are not setting up saving the model per se, but what they are saying is if I pick up a model here, let's see. Yeah. If you go to artifact, okay, so this is also, I should have covered actually. So now for the last one only we did auto logging. So it has logged more data what we have been doing earlier. So the example can be, for example, when I did auto logging, it has enabled to download, it has enabled us to kind of log the model. What is the model, what we have built. Now it has also logged, if you have to build this model on your own, what are the tools you would require, because to run this model, you would require all of these packages, correct? So it is telling us that you can take this particular set of meta information and then you can deploy this model anywhere, correct? So think about, we can take the entire folder, put into, like, copy it entirely as it is, and to run this model, I would require these packages that telling me what is required. If you're running under Conda, what is required here? If you're running under Python 1, what is required here? Correct? Or on a regular machine, what is required here? So you can take these packages, install on a given machine, and you put this model, you can execute it in a way. That's what it's saying in general. So why did I come here? Actually, is yeah. So what I was talking about run, right? So what happened is now yeah. So I'll go back to that other thing. So if I want to serve a specific run, so currently either you can put into a model. So for example, we have not done that particular part right now. I'm in the experiments only. For my given experiments, I have a given run ID which has been given to me, right? Which I know. This is my run ID, correct? So what I can do is I can um, serve the model locally and then perform it, whatever. But I could not do it at this point of time when I tried last. What I can do next is I can then take MLflow and build an image out of it. So I'm saying that ML models, my MLflow models build Docker, and I can give a specific run ID as you can see here, right? So now this run ID can be of a model which you want to keep into staging. For example, look, let me actually show you one thing here. So not alias, yeah, promote model here, right? So what can happen is a given model um, can be into stages like staging, production, and all that stuff. I think I should do something. I try to do it next time maybe, but assuming that you have a model which you can put into staging, production, and all that stuff, and now you want to take that model and not model per se. Okay, so let me just quickly correct my things. Okay, let me I think come back next time when I have more information. But for now, I think what we can do right now is simple. Understand, we did a run, and this run we know has a better performance, and we know that we also got a model out of it as well. So what I can say that for this given run, which is this ID, whatever model is being built, right, take into and put it to a Docker image. So this command is going to build a Docker image out of it for us, correct? And once we have done that, we can use kserve. This is given example of kserve example here. So assuming that you have deployed kserve, which is inference service, we can use this inference service to serve our model. So I'll try to run this example next time, but not right now. But that is how it is going to be. So it has a deployment hooks in a way. That way you can say MLflow go and do a deployment at some endpoint. Hope it
Is there
makes
a way
sense.
to refer to a model by its tag? So if you've
Yeah,
promoted a
I
model
think so.
to
Yeah, you can.
production,
Yeah, you can do that.
instead of its run ID.
Yeah, so we have not covered that particular part, but you can also give a model a given tag, and then as I mentioned earlier, right, you can make a model into a different stage of promotion, like stage of staging and production, all that stuff as well. So I'll try to explore it next time and then show you and try to. And if anybody wants to take it further from here, I'm perfectly happy to do that as well. If any of you want to kind of take it further and try it out, it's also perfectly fine. Okay. Anyway, let me know if you can, if you want to, but that's fine. So now, once we kind of finish this next part, right, understanding a bit more of MLflow in that one more session, then I think we would be kind of not here. Sorry, a different one. Okay, where is it? Yeah, here, right? So what we could kind of cover is how we can understand MLflow. So one that is part has been covered. The remaining part, according to book, what we have is there, right? It's kind of building pipelines, something like that, right? So we want to explore that, or we can do without that as well. So we'll see. So once we looked at this MLflow in the next week, I'll try to go back into the book and see where what has been left. And once we're done that one last topic, that one which is there, I think with the Spark, we can build some of the pipelines, which there can be other ways of doing it as well. So we'll maybe spend one more session on that, one or two more, and then we can go back to the book and look at the final demo which the book tried to convey to us, right? Some kind of flight thing and all that stuff. But I think, yeah, it would be then kind of at least book part is going to get covered in the next 3-4 sessions. Yeah. Okay. Hope it was useful. Any feedback? Anything you have to share?
This is really awesome. Thank you.
Yeah.
Yeah, no, amazing progress. Well done. You can really see it coming together now, particularly with MLflow. Yeah, I think we're saying that Kubeflow wasn't a good choice because we needed Kubernetes infrastructure. Was that right?
Yeah, it would take a lot of efforts, but let's see once we finish with our entire example, let's say we can spend maybe one session for a Kubeflow also, we should do it actually, right? Because Kubeflow has also been used in the industry.
It might be interesting to compare. Yeah.
Yeah. So we'll see once we
That's
finish.
amazing. Yeah, no, that's amazing progress. Well done.
Yeah. Okay. Great.
Yeah.
Cool. Okay, guys. See you next time then. Yeah.
Bye.
Cheers, guys.
Thank you very much.